Hello, friends. Welcome to our channel. Let's have a look at problem 3362, zero array transformations 3. In this video, we're going to address this problem using two heaps. So one is a min heap and the other is a max heap. So here I'm not going to read through the problem statement, but I want to emphasize one thing. This is the second bullet point. The amount by which the value is decremented can be chosen independently for each index. This is very important, right? So here we have three examples. So the example 3 is one which you cannot do, right? You return -1. And here the length can be as long as 10 to the power 5. Therefore, we need to think of time complexity. So with that said, we know here there are some hints, right? Actually, we are going to use in the two explicitly. So with that said, let me first demonstrate to you some notions and some idea. So first is, how do we do the counting? This problem requires us to return the maximum number of elements that can be removed from the queries. What we want to do actually is we find the minimum queries needed. Let's call it count. And then we use the length of the queries minus the count. This will be the return for this problem. So this is one thing. And this thing is about a simple fact based yield from the bullet item 2. So in other words, to make the array a zero array, we shall have for each index t, or you can use index I. So t is in this range, right? So we have at least nums t count of intervals or queries such that so this intervals cover this t, or in plain numbers, it means L is less than or equal to t, and t is less than or equal to R. So these two actually are very simple, but very important for the coding. So next will be some notions and questions. So those will help us understand the code. After I introduce these notions, I'm going to do the coding. And in between, we are going to make it aligned with this notion and questions. So you can try to digest. Afterwards, it might be best you run it manually to really digest the pattern and the code. So first, I'm going to use t as a turn time. You can understand it as index. So for example, some people prefer to use index I, this the one. So we have a available. So this is the min heap, but actually we want to use a max heap behavior. Therefore, we store the negative r's. In other words, the right end. So here, these r's corresponding to queries such that L is less than or equal to t, right? So this is the one. So in other words, the corresponding intervals can be used to decrement nums t later. But this is not complete yet, because we need to think of this available together with this assigned, right? Next, let's look at assigned. So the assigned is going to store r's for those intervals L and R, such that R is greater than or equal to t. So in other words, the corresponding intervals can be used to decrement t. So actually, the assigned will be uh, appended by the element from available. Therefore, the corresponding interval will have this relation. This is the one thing to be noticed. So with these three notions, let's look at some questions. The first question is, how do we know for a given time or index t, we can decrement nums t to be 0, right? So the criterion is that the corresponding assigned this array or this heap is greater than or equal to nums t. This is actually, at this point, it might be not that straightforward, but if you look at finish question 3, would be very straightforward. So just one thing. Another thing is that how shall we use the queries? So we are going to greatly use queries with larger ends. So here, for example, I can use this one. It's much better than those, right? So this is the question 2. It also means that we need to sort the array, right? So the third question is how to do assignment. So here the answer is transition from available to assigned. So basically the idea is that given a time t during the for loop, so if available will contains negative r's corresponding to intervals with l less than or equal to t, as we mentioned here, right? And then if the negative r's in available are such that the corresponding r is greater than or equal to t, this means the corresponding interval L and R include T or covers T, and can be used to decrement nums T by 1 if needed, right? So the major operation is that we pop these negative R's from available and put those R's into assigned. This also explains question 1, why the length of assigned is greater than or equal to nums T, implies that we can decrement nums T to be 0, right? So if we can decrement all nums T to be 0, it means that we can do such a thing, right? In other words, avoid the situation as example 3. So with these questions went over, so let me do the coding. So we are actually going to make correspondence of the coding with these notations and questions, and you can try to follow up or do some manual walkthrough. So here, actually, we can sort according to the first. So you can add a key, or you can choose not. But for complexity, explicitly, so we can see x naught. In other words, this is sorting according to the left ends. So if you do not include this, this is also fine because this is the default behavior. So this is one. And then I'm going to initialize the two available. This is the heap, and assigned another heap. So this available is going to store negative r's, right? So this assigned is going to store positive r's, right? So then the count of needed queries, we set it to be 0, and the current interval we are going to count is to look at is 0, right? Then we can do the for loop. So for t in range n, let me introduce this n. So n will be the length of queries, length of nums, right? We need to uh, decrement all the elements in nums to be 0. So first we are going to check, well, assigned and assigned 0 is less than t, right? So look at here. Assigned is going to store r's such that r is greater than or equal to t, right? So if this r corresponding pop element smallest is less than t, right, we're going to do a pop operation. So it's going to be heap q, heap pop, right? Pop from assigned. So the result of this while loop is either assigned is empty or the top element is greater than or equal to t. In other words, all the remaining elements in assigned will be greater than or equal to t, right? So this is the one. Now we are going to push elements to available. So while q is less than the length of queries, so here k is tracking the queries we're going to use. If this is less than length of queries, right, and the corresponding queries at key, the corresponding left, if it's less than or equal to t, so we shall push them to available. Notice that available is going to store negative r's corresponding to L that is less than or equal to t. So here, if it's less than or equal to t, what shall we do? If Q, if push to available, the queries, Q. So here is the end, right? But we put negative because we are going to use the first going to use the um, query or the interval corresponding to large R's. So this is exactly here, right? So with that done, so what we have, so once we push the one, we need to increment this key by one. So here afterwards at the current state t, so this available will contain all the intervals corresponding to that the else is less than or equal to t, right? So this is the available state. So now let's do the transition. So now we look at the current time t and the current nums. So we want to see how many available intervals are good to cover the index t, right? So basically, while length of assigned is less than nums t. So if it were greater than or equal to nums t, so we don't need to go into this while loop, right? Because we can already decrement this nums t to be 0. So this is the one. And if available is not empty and available, so the top element corresponding to largest ends, if this ends will be greater than or equal to t, what shall we do? We pop these r's. So we pop these r's. So r will be negative hip to hip pop from available, right? Then push this r's into available, into assigned. So basically hip to hip push, we push to assigned. So the r, right? So notice that if we do not add assign, because available stores negative r's, that's why we should put negative here, right? So this way, each time we push one query to this assigned, it means that we need this query. So we are going to do the count because increment by one. So then basically, if you do not exit this while loop, that's fine. If you exit this while loop, basically it's either this one is validated. In other words, length of assigned is greater than or equal to t, or available is empty, or this available will not cover t, right? So, but we don't know in which one, so we want to do a check. If length assigned is greater than, uh, so it's actually we can do early stopping. If less than nums t, in other words, we cannot finish, so we are going to return negative one. Otherwise, it means that this guy is greater than or equal to num t. We just continue, right? So then after this for loop, we just need to return length of queries minus the count. So this will be the full logic for this problem. So here, this one actually corresponds to this question one, right? So now let's do a test. Yeah, it passes all the cases. So now let's look at the generic case. It passes all the cases. So I guess now after you've seen this code, you can do a correspondence with these notions and the questions. But in order to better understand that, so we can do some prints. This will retrieve the code process. So queries. So this is the queries after sort, right? So now I want to print this information. So print f the current time or current index. And then I'm also going to print the information, right? Print so nums at t. So it's going to be nums t, right? And also I'm going to print what's the state of assigned and what's the state of available, right? And what's the state of t, right? And also, if you like, you can also have the count, right? Now let me print that out. So let's look at the first one, right? Let's use first example. So when the query of the sort is this one, right? So at t equals 0, so assigned should actually use do the transition. because available should contains all the interval corresponding to indices less than or equal to 0. So this corresponding to originally available will be -2, -2, right? After the transition to assigned, so the assigned should correspond to intervals cover t equals 0. So this one and this one, right? Because this assigned has length 2 is greater than this one, right? So in other words, we didn't enter this, so we didn't enter this if condition. So this t equals 0, and then t equals 2 now, right? So in t equals 1, so when t equals 1, so notice that assigned is still sufficient to use, but because this 1 is less than or equal to this t, so we should put this -1 so it's available, right? And then when t equals 2, still assigned has enough interval to use, right? So and available still maintains this state, and the k is 3 now. Um, so in this case, count is 2. So overall, we are going to return 3 minus 2, that is 1. So this is the first example. The second example, the queries after sort is like this, right? So then at t equals 0, so you can only contain this one, right? But this is enough to use, so you can count equals 1. Then at t equals 1, so basically you should have also have this, so this 3, because this 1, 1, 1 is less than or equal to t. So it's going to add it to available, because we are going to add this one, and this one, and this one to their negative, right? So this is the one. But after all these intervals are added, so the key will point you to 4. In other words, we have pushed all the queries into assigned or available. So when t equals 2, so here, so here nums at so t equals let me here actually this t yes, it's 1. So assigned is 1. The length is actually not enough. So we are going to hop 1. So from to the available, right? Oh no, sorry, because the t is 1 is still sufficient. So we don't need to pop. So when t equals 3, right? So in this case, so um, assigned is 3. So let's see, it should have something more. But this is already returned. Let's see. But the count is 4, right? So here actually, so assigned is we should have a list 2. What's the so sorry, I guess I just got lost. So here t is still 1. So assigned is still good to use, right? So but here this one, because this is assigned is less than this 3, we should pop it, right? So this is actually correspond to this line, this value, right? So we're going to use this one, right? So then the count will be 2. So in other words, we can use one of this interval and one of this interval, right? So overall 4 minus 2 will be 2. So this is the second case. The third case of this query is like this. So on t equals 0, so because this is less than, for sure, less than or equal to 0, we have this one and the variable is 0. And this t is 1, but your assigned is also this 1. This is okay. We count by 1. And nums in and t equals 1. So nums and t is 2, right? So assigned is still 3, corresponding to 1 interval. So you are going to check this condition. So length assigned is 1, none is less than 2. We are going to return -1, right? So this will be the full walkthrough. So I guess um, for the one who explained this, right? So it's clear. So about the notions and the questions and the thought process. For the ones who listened, it might still be confusing. But I guess the best way to grasp is to have a manual walkthrough on this code. So before we end this one, here actually you can just put this one here. Use just a one line. That will be also sufficient. You can put a comment here and comment here and comment out here and test again. Yeah. So with that said, I guess that's it for the current video. Thank you for watching.